Welcome for this lesson. We want to look at questions involving the use of logarithm rows. Now, it's important for you to understand the logarithm rows. Logarithm rows are actually very related with indices rows. So, I'm not going to write the rows, but as I do this one, you will be able to see the rows coming out clear. Now we have 4, given that log y is equal to 3.143 and log x is equal to 2.421, evaluate a 4 log y raised to power a half plus log cube root of x. But from the word go, you need to understand that if I have the cube root of 25, or let me say 125, if I have the cube root of 125, this one in other words can be written as 125. I remove this cube root by raising it to power a third. So 125 raised to power a third is exactly the same as the cube root of 125. Root 16. Root 16, we know it is 2 here. So this is simply the same as 16 raised to power a half. If I have 32, 50 root of 32, 50 root of 32 is simply the same as 32 raised to power 1 over 5. Having known that, this one is going to be very simple. Now, in rows of logarithm, we know that if we have a log a raised to power x, if this is the power, this is exactly, this power comes here, we have x log a. So this and this are the same. This and this are the same. From the rows, the power comes here. And this is, so when you understand that, this one is going to be very simple. In our solution, bring the power to this side. So we will have 4 times the power, which is a half, log y. Then plus log, this one is the same as x raised to power 1 over 3. This is the same as this. And we know the power is supposed to be here. So this is the same as this, then it is going to be 2 log y plus, bring this here, a third log x. Now that we have log x, log y, log x and log y, we can now substitute the correct values of the log y that we were provided with. So this is 2 into log y, and log y is 3.143 cross plus a third log x, and our log x is 2.421. Having that, you take your calculator and get your value. So this is 6.286 plus 0.8103. And then you add, and the final answer is 7.0676. So that's how you handle such kind of cases. So I want to do part B. Part B is log x raised to power 4 minus a quarter log y raised to power 3. Simple way, understanding the rules of logarithms, that's very simple. Now bring the power to the left. We have 4 log x minus, bring the power here. We will have 1 over 4 times 3 the power, because this is the power and this is the power. If I take this here, it's going to be another power. Log y. Our intention is to ensure that we have log x and log y alone, not power. Then now substitute with the log, that is 4 log x, and our log x is 2.4 to 1 minus cross. This is 3 over 4 into the log of y, which is 3.1. Then you multiply 4 into 2.41. Sorry, we have that already. This is 9.684 minus 2.357. So, and that is how. Question involving the use of rows of indices. We have this solve for x. 9 raised to power x plus 1 plus 3 raised to power 2x plus 1 is equal to 36. First, you are told that ensure those numbers that can be written to the lowest base, write them. And those one cannot, leave them. So here, I can see the smallest base, the least base I have is 3, so but I can now write 9 in terms of 3 to base 3. This is 3 raised to power 2. 3 raised to power 2 is 9. This is the power, and we have another power. Open the bracket, x plus 1. The power that was there. Then plus 3 to x plus 1 is equal to 36. 36, you cannot write it into power this, but I will show you how you can write this. But I have 2 methods to do the first method. Leave 36 alone because it is not obvious for you to write this one to power 3. Right? If it was 27, fine. If it was 27, we could write 3 to power 3. But now that's not the case. This is 3 raised to power 2x plus 2. I'm opening this bracket, plus 3 2x plus 1. Now here, this is what you need to understand what that one is. Let me remind you what this is. When we have 5 raised to power x times 5 raised to power 2, the bases are the same, and it is multiplication. What does the rules of indices say? If it is multiplication, you take one base, then add the powers. So this one will be x plus 2. So this and this is the same. So if I give you this, is it impossible for you to bring it to this side? No. If now you have this, what you understand is that the base is 5. So you write 5. Then the power is x plus 2. That means it was multiplication. So the first is for the first, and the first power x is for the first base. Then plus means it was multiplication. This one is for the other power, and then 2. So this is this one, and this is this one. So once you have that knowledge, this one is going to be very simple. Therefore, this one is 3 raised to power 2x times 3 raised to power 2. Then plus, this plus here. 3 raised to power 2x. This is addition, there means times 3 raised to power 1, and the answer is 36. Very important. Once you have done that, now you can let 3 raised to power x, 3 2x, b, any letter of your choice. Take y. So where you see 3 raised to the power 2x, substitute with y. The first one is here, so this is 9 times y, so this is y times 9 plus y times 3, and the answer is 36. 9 times y, that is 9y plus 3y. 9y plus 3y, we have 12y is equal to 36. So if we want the value of y, we divide by both sides by 12. Divide by 12, divide by 12. So we have y is equal to 3. That is fine. We were not looking for the value of y, but we were looking for the value of x. But we said, let y be 3 raised to the power 2x. So this y3 and this 3 raised to the power 2x is the same, they are the same. Therefore you remember, but y is equal to 3 to raised to the power x. 3 raised to the power 2x. So it means that this 3 here is equal to 3 to x. Now here, any number written like this is always raised to the power 1. So you can see that the bases are the same. You ignore the bases and you say 1 is equal to 2x. And then it means that the value of x, you divide by 2, and the value of x is equal to a half. So x equal to a half. So that's how you handle that kind. But let me try to write this 36 method 2. You can do with method 2. So method 2, I'm going to try, this one will remain the same. I'm going to try and write 36 in terms of base 3, and we will see that one. 36 actually is 3 raised to power 3, that is 27, remaining plus 3 square. Let's check. That is 27 plus 9. That is true. So let's start here. You have written this one to be 3. 2x plus 2 plus 3, 2x plus 1 is equal to 36. Now I want to write this 36 in terms of base 3 to ensure that the bases are the same. 3, 2x plus 2 plus 3, 2x plus 1 equal to 36 is simply 3 raised to power 3, which is 27, plus 3 raised to power 2, which is 9. Yes, that is 36. 27 plus 9, the answer is 36. Now that the bases are the same, ignore the bases and deal with the powers. So this is 2x plus 2 plus 2x plus 1 is equal to 3 plus 2. We are dealing with the powers only. Now like terms together, 4x plus 2x plus 2x, 4x. This plus this, that is 3, is equal to 5. Take this to the other side. 4x is equal to 5 minus 3. 4x is equal to 2. Divide by 4. Divide by 4. X is equal to half. So that's how you can handle that using method 2. Solve for x here. Rewrite this, the smallest base you can see is 7. So rewrite this to base 7. 49, that is 7 raised to power 2, that is 49. But 49 had a power x raised to power 1, x plus 1. So put that power here, x plus 1. Itaigeyamo, kakasiri. 7x to x is equal to 350. So now deal with this. This is 2 times x to x. 2 times 1, that is 7 raised to power 2x plus 2 plus 7 raised to power 2x equal to 350. Now this one is the same as 7 raised to power 2x times 7 raised to power 2 plus 7 to x equal to 350. Now, where you see this one and this one are the same, you say let 7 raised to power 2x be k, and letter of your choice. So where you see this one, substitute with k. So this is k times 49, this is 7 square 49. So we have 49k plus k, and the answer is 350. So 50k, this is 49k plus k, 50k equal to 350. So we want the value of k, you divide by both sides by 50. K equal to 7. But we said that k is equal to 3. So this 7 is the same as this. So 7 2x is the same as 7. The any number written like simply like this is simply raised to power 1. So the bases are the same, we ignore them, and then it means that 2x equal to 1. We want the value of x divided by 2, and also here x equal to a half. So if you want to use method 2 here, you need to write 7 to this one, to base this. So what is that? The only thing you're going to change is to write this one. So from here, you will write this in the powers of 7. That one I find challenging for some students, but if it is easier for you, this one 350 is the same as 7 raised to power 3 plus 7 raised to power 1. Yes. What is that? Yeah, that is correct. 7 raised to power 3 is 343. 343 plus 7, the answer is 350. So you can, 350 is the same as 7 raised to power 3 plus 7 raised to power 1. You substitute and you can get the same answer here. Aya, mwenye kwanta kuja.